Hello, everyone. I'm starting the next stream right now. So, first one of the TV screen, or those who are watching go to the Racket YouTube channel, and you should see the next stream. I'll see you on that in just a moment. All right, hello everyone. Welcome to the third session of the first day of RacketCon. We have an illustrious number of people right now. We've got 42 people, which is a very auspicious number. Today, this session, we're going to continue. Kind of the first session was, there's definitely like a streaming, threading vibe going on with that first group of talks. And that'll show up again a little bit here, especially with Bogdan's. And also, both Bogdan and Ryan will be talking about, beautiful ways to interface with, things outside of the Racket ecosystem. Can I get you, Bogdan and Ryan, to say hi?
Hello. Hello.
Cool. We'll do the same process as before. So if you're in the gather, you want to go to one of the TVs. And then you can put your questions for either Bogdan or Ryan in the Google Doc that's at the document podiums. And you can put those anywhere. And we'll watch Bogdan's talk. And then afterwards, we'll have Bogdan's questions. Then we'll watch Ryan's talk, and then we'll have Ryan's questions. And then after that, we'll go to the gather again for the hallway session, where Bogdan will be in the upper left-hand corner, Ryan will be in the upper right-hand corner. I'm going to turn off the video and audio for everyone, and then switch over to start streaming Bogdan's talk. So just give me a moment there. Thank you.
My name is Bogdan Popa, and today I will be talking about GUI Easy, a library for declaratively building graphical user interfaces in Racket. Racket comes with Racket GUI as part of its main distribution. Racket GUI is a cross-platform toolkit for building graphical user interfaces. It's powerful and flexible, having been used to build the Dr. Racket IDE, and part of that power and flexibility comes from the fact that it's built on top of the Racket class library. Unfortunately, that also means that the API that is exposed to the user by Racket GUI is fairly imperative. In addition, Racket GUI is unopinionated concerning state management. So it's up to you to figure out how you're going to keep track of state in your application, and more importantly, how you're going to synchronize that state with your user interface. GUI Easy is my attempt at adding a declarative layer on top of Racket GUI, and I believe it achieves this in two ways. First, by hiding away the details of the class system and providing just regular functions for the user to use to construct the view hierarchy. And secondly, by providing an abstraction for keeping track of state within an application and automatically propagating state changes to the views that depend on those particular bits of state. This also means it's less flexible than Racket GUI. In particular, you cannot opt out of the state management abstraction. Here we have an example application built with Racket GUI on the left and GUI Easy on the right. I can run both of these and I get roughly the same result. So it's just an application where you can increment and decrement the counter. In the Racket GUI version, you can see that every widget is sort of imperatively constructed. So we create a new frame, then we create a horizontal panel, then we pass the frame as the panel's parent, then we create the 3 widgets within the panel, and in these cases as well, we pass the panel as the parent of the button, the message, and the other button. In contrast, in the GUI Easy version, the source code more closely corresponds to the final layout of the application. So we have a window with a panel inside of it with 3 other views inside of it. Then when it comes to state management, the Racket GUI implementation uses a mutable variable to keep track of the current count, and it has a function that is in charge of changing that count. And then an additional sort of responsibility of that function is to propagate every change to the count to the text field or the message field that depends on the counter. In the GUI Easy version, we wrap the counter in an observable value, and then GUI Easy knows how to propagate changes to that value up to the views that depend on it, in this case, the text view. So when the button's callback runs and changes the count, the text view is automatically updated with that new count, and we don't have to do anything ourselves. So the basic building blocks provided by GUI Easy are views, and views are just regular Racket functions that combine to form the GUI hierarchy, and they know how to respond to changes in the observables that they depend on. So, for example, a text view depends on its input message and changes the label whenever that message changes. A choice view may change the selection whenever its selection input changes. A canvas view will apply its painting function every time its input data changes. And then observables are like boxes that have the ability to broadcast changes in their values to observer functions. So we can define an observable and then subscribe a couple functions to it and then push a change to that observable. And when we do, both of those functions trigger. And in this case, both of those functions just print the new value of the counter to standard out. Observables can be mapped. So we can take that previously defined count observable, apply a function to it, or map it using a function. In this case, we're just squaring the value. And then just like with regular observables, we can subscribe functions to these ones as well. And now when we push a change to the original count, both of its original observers trigger, as well as this new one that we've subscribed to a derived observable or a mapped observable. However, derived observables cannot be updated. And so if you try to update the count squares observable, that leads to a contract violation. Sometimes you might have to drop down and implement custom views, perhaps to wrap a new widget in the GUI library or a custom one that you've developed. And this is fairly straightforward. Every view must implement the view interface, which is made up of 4 methods. Every view needs to be able to list the observables that it depends on. And that could be an empty list, in which case it'll be a completely static view. And then when it's first displayed, it needs to be able to create the underlying widget, the underlying Racket GUI widget. And then it needs to know how to respond to changes in its observables. And finally, it has the ability to perform any sort of teardown actions when it's no longer being displayed. And so the life cycle looks something like this. First, its parent will ask for its dependencies. Then its parent will ask it to create the underlying widget. Then its parent will send it any changes in those dependencies while it's being displayed. And then finally, when it's no longer going to be displayed, its destroy method will be called. Here's an example custom view, which is just like the built-in text view. It has a single initialization field, which is an observable of a message. It then lists that observable as a dependency, and when it creates the widget, it instantiates a Racket GUI message class and gives it the current value at the time of the message observable as its initial label. And then finally, whenever the message is updated, it propagates that update to the underlying widget by changing its label. And there's no teardown that it needs to do, and so its destroy method is a no-op. Finally, we wrap, to hide the details of the class system, we wrap the instantiation of these custom classes in a function, and then we can use those functions just like we would any of the built-in views from GUI Easy. Next, I'm going to demo building a simple application just to show you what it feels like to use the library in practice. For this portion of my talk, I'm going to make a small front end for a debugging library that I've been working on. So I'm going to use Lang Racket base. I'm going to require the client portion of that library. The details of the debugging library aren't very important. It's just it has a client server model, and I've got a client running in the background, so we can test the UI against it. I'm going to require Racket GUI Easy. I'm also going to require Racket format because I know I'm going to need it. And to begin with, I'm going to define a function to run the UI. For now, it's not going to do anything. And I'm also going to define a test submodule to run the GUI with a connected client. And the reason I do this is because Racket mode for Emacs makes it easy for me to run my test submodule just by hitting a key binding. So now if I change this to render a window, maybe whose title is remote debugger, and maybe the window contains some text that says hello world. And now I run my tests, I get a little GUI. All right, and maybe let's also make that window a little bigger by default. So 400 by 300 pixels. There we go. And now I can use the client to get some general metadata about the server. And now let's try to display some of that metadata. Maybe we want to display the operating system. And that works, but obviously that doesn't look great. So let's nest these two inside of a H panel. And that's better. And now maybe let's also display the Racket VM and the Racket version. There we go. Obviously this isn't ideal. We'd want to get rid of the spacing here and also align the values vertically. So let's introduce a helper function called labeled. It's going to take a string label and some arbitrary view. It's going to nest them inside an H panel. And for the text, it's going to nest it inside of an H panel with a minimum size, where let's say the width is 100 pixels and the height can be anything it needs to be. The nested H panel is also not going to stretch horizontally. And now let's convert these. Cool. Now we still have the spacing problem, so we have to convert to tell the outer H panel not to stretch vertically. Whoops. So we want it to stretch horizontally, but not vertically. Cool, that was good so far. And now let's extract the info bits into their own little view. Nest them inside a vertical panel. So, whoops, I called this get info. I should have called it info tab. All right, now we can get rid of that. And our GUI is the same. And the reason I did that is because I want to introduce another built-in view called tabs. And what tabs does is it, displays a tab view. And the first argument of the tabs view is the list of tabs. In our case, that's going to be info and memory. So, and then the second argument is an action function to run whenever a tab is selected or whenever they're reorganized. And that takes an event, a list of choices, and the current selection within the list of choices. So when the event is select, for now we're just going to print the choices and the selection. And then the final argument is going to be the contents of the tab, the tab view. And so in this case, even though we're now selecting a different tab, because our contents are static, they don't change. But as you can see here, the action does fire and our sort of printf expression runs. And so now what we can do is we can introduce a current tab observable, and by default it's going to be info. And when a new tab is selected, we can update that tab observable and set its value to the current choice. All right, and then for the contents of the tab view, we can use a case view to dispatch on the value of the tab. And so when the tab is info, we display the info tab. When it's memory, we display, well, for now, let's just display the text memory. And then we also need a fallback, even though for us, this is not going to be reachable. So we'll just maybe add the text unreachable here. Okay, and now we can switch between tabs. And let's add a view for the memory tab. It's also going to take a client, text. All right, so our view looks the same still. And for the memory tab, let's get the total memory use and wrap it in an observable. So get memory use from the client. And then let's also get the total object counts from the client. And then for the memory use, let's use our labeled helper from before and display the total as text. Okay, so that works. The total is in bytes, so maybe let's add a little helper function here to convert the bytes to megabytes. So divide the bytes and then convert to a string. All right, now we have the total in megabytes. And for the counts, we're going to want to use a table view. And so let's introduce a vertical panel here and use use a table view. So the table view takes as its first argument a list of column names. So our first column name is going to be kind, our second one is going to be count, and then size. And then its second argument is the data as a vector, or an observable of a vector. So we're going to take our counts, which is an observable of a list, and then convert it to a vector. And we can provide it with a way to, given an entry in the vector of rows, give it a function to map that entry to a vector of columns. And so we just take the entry and grab its car, which is the kind as a string, the kind of object, and then the catter of the entry, which is its count, and then the cadutter of the entry, which is the size in megabytes. So I'm going to use my little megabyte helper there. And there you have it. We have a little table with object counts and total size. And now to make this feel a little bit more dynamic, I'm going to introduce a button that's going to say like reload, and then when we hit that button, we're going to update the total and just assign the current use to it, and the same thing for the counts. Get object counts. Okay, so now I can come here and reload my data. Let's get rid of the spacing there. So it's going to stretch horizontally but not vertically. And yeah, there we have it. Hopefully this gives you a taste of just how easy and natural it is to put together these GUIs using GUI Easy. Thank you for attending my talk. The library and its documentation are available on the package server, and you can find the source code on my website at defen.io. Alongside the source code, you'll find several example applications, so I encourage you to check those out if GUI Easy appeals to you. Thanks.
Excellent, Bogdan. Hey, so let's do questions now. So first question is, okay. So there are a few technical questions, and then there are a few kind of broader ones. So as like a broader one, you showed how to GUI Easy allows you to do something to build a GUI in this like declarative way. And it feels extremely close to be able to building something that is like almost a no coding tool at all, where you can have like a user interface designer use something that is a GUI Easy based DSL to build like an interactive prototype and an interactive program. And what are your thoughts about that? And do you think that is that something you're interested in? Do you think that's feasible for building something real with almost being able to ignore like the technical details of observables?
Mm-hmm. I think you could definitely hide some of these aspects away further. I think that's not really my goal here. My goal, like the intended audience of GUI Easy is someone who's a programmer, right? And it's me basically. But yeah, you could definitely take this further and maybe even go in some sort of an HTML type of direction, right? You'd lose some power presumably by going there, but you could do it. And then prototyping by a UX person could be feasible, but that's not the direction I'm aiming for.
Cool. Okay. Now, you showed how a custom view has to obey this like particular interface, and the way that I kind of think about that is that basically that custom interface of view is like that structure is really the thing that you're providing. Like you came up with that that abstraction, and then you went and implemented that for each one of the different things that are part of the Racket GUI system. And people are curious about like, what can that not expose? So for example, you know, could that expose, I don't know, the window context for doing OpenGL and Vulkan stuff? Or would that be something that is too deep to expose? Like, you know, when you designed that abstraction, did you have in mind things that you didn't want to, that you wanted to completely hide and be inaccessible? Or what are your thoughts about that?
I think that abstraction allows you to do, if you dive down to the level of custom views, then you can do pretty much anything that Racket GUI lets you do. And so you could definitely create a custom window view that exposes that GL context. And in fact, the window view provided by GUI Easy actually lets you hook in a mixin to wrap the window object. And so you could do it that way. And then there's also just specifically for canvases, there is a canvas widget that already gives you a drawing context that you can use. And so you don't even need to do all of this because the library provides it for you. But yes, to answer the original question, you can definitely dive down to that level. And the abstraction will mostly let you do, I think, pretty much anything that Racket GUI would.
That's cool. Okay, now I think someone is asking a question about like what kind of widgets are available. So they say, can you partition all available space into a grid and then assign widgets within areas of the grid? So I imagine when they say grid, they mean like, I feel like normally when you think about GUIs, you often think about them in terms of, well, there's a horizontal stacking part and then a vertical stacking part, and you kind of like interleave those. But you have a widget that basically just says, I want to divide up the screen into you know, a 3x3 grid or something like that.
No, but you can achieve that by combining the horizontal and vertical panel views.
Mm-hmm. And you could presumably use that to like build an abstraction that simulates, for instance, like the CSS grid model. And exactly. It's plausible to me, at least, that it would be easier to build that abstraction targeting GUI Easy than it would be to think about it targeting Racket GUI itself, just because there's so much, you know, boilerplate that you're hiding.
Yeah, I think so too.
Cool. Okay. Now here's like a really specific question. Is the result of case view different than a map obs result?
Yes. So case view returns a view. Okay. It itself is a view that knows how to change its children as its input changes, whereas obs map would return an observable, and so you would get a contract error in that position because an observable is not a view.
So basically, like the case view, you know, in the model view controller way of thinking about things, the case view is the view, and the observables, they're the model. And so they just don't connect one another. So even though you might think of it as, oh, it's one of those, it's something with a function attached to it. It's a different kind of thing with a function.
Mm-hmm. Yes, exactly.
Okay, cool. Okay. There's this cool benchmarking tool. When I say benchmarking, I don't mean like performance, but benchmarking in terms of like expressiveness. It's called 7GUI, where 7GUI is like a list of tasks where you should try to do these tasks to show how your GUI is really awesome. Are you familiar with this, and have you done the 7GUI tasks in GUI Easy?
I'm aware of it, and the repo for GUI Easy has an examples directory. I don't think it has all of the 7 GUIs, but it has some of them at least. But as far as I remember, it should be able to do all of them without issue.
That's cool. Cool. Now, that view infrastructure that you came up with, and the concept of an observable, I mean, you're using them for GUIs, but they're really just a general sort of flow-oriented programming idea. And you know, sort of do you see value in using them outside of GUI Easy? And B, like maybe there's something that you know about how the implementation works where you're like, yeah, you might think that it would work, but actually there's this really GUI specific thing that's hidden there that you might not pick up. What's your take on that?
There's nothing GUI specific about them, so they could definitely be reused. As far as using them outside of GUI Easy, I haven't really thought of use cases, but they are sort of, yeah, you could totally use them and be fine.
Do you think that you could take a GUI Easy program and just sort of change something underneath the covers, and then now it is a glorious terminal application? Because there are some people who know that windowing toolkits are lame and that pixels and colors, I mean, these are for the weak. That true people, they use only text terminals all the time. And so, but I really like how GUI Easy looks, but I want to do it for a real GUI, i.e. a real user interface with only text characters.
The way the library is implemented right now, you couldn't, because the interface specifies that you have to create real Racket GUI widgets. But obviously that could be abstracted away and you can provide, generalize over that.
But you're not sold on this.
No, not really.
Now, what about targeting web? I feel like this feels very similar to me to like the React model of web applications. Were you inspired by that? What do you think about that?
Yeah, React was definitely an inspiration, although the model is slightly different here. This is still a retained model. We're just putting a declarative layer on top. We're not re-rendering the whole world with every sort of iteration like React, or a diff of the whole world. But yeah, I feel like for the web, there's tons of solutions. I feel like this is specifically for desktop GUIs, and that's what it's intended to be. And I wouldn't want to go to a lowest common denominator sort of thing. And I would rather just it be a really good solution for developing GUIs.
I buy that. Okay, now the custom view % thing, that kind of tells you how to embed an existing Racket GUI thing inside of GUI Easy. What if we go the other direction? If I already have a GUI application and I want to rewrite a portion of it to use GUI Easy, is this feasible, or is it not going to work?
It's feasible at the window or dialog level. So whenever you spawn a new window, you could, in an existing Racket GUI application, just call render with your parent window as the input to that render function. You can actually pass a parent, and then everything would be taken care of for you. So you could combine the two, but it has to be at that level. You can't go lower than that.
And like, what's the technical reason why you couldn't go lower than that?
It's because at that level is where all of the dependency tracking happens. So it's just an arbitrary point that I chose. It is possible that I could come up with a way to let you nest these things at the widget level, or widgets other than windows, but yeah, it's just not something I've worked on. Yeah.
So maybe to understand that, help me understand that, there has to be a place where as you said, we actually do the dependency management, and exactly. You did that in the window. You could
yes, I did that in the render function. So something you call render and you pass it a window view, and then that takes care of everything. But yes, there has to be a point where we collect all the dependencies and then figure out where to send any changes.
Yeah, and so you could imagine, for instance, that your library would like create a thread on the side, and that thread on the side would be like the one place where all the dependency management was happening, and it would like talk out to this window or to that widget or to whatnot. But you've found that it's been more convenient to stick that in the window, and that limits how the composition can happen.
Yes. Yeah. Because composition width exists, that just wasn't something I was thinking about. But you know, if people start using this and then they feel like that's a good use case to support, then I feel like I would definitely want to support that.
Cool. Awesome. All right. So that's all the questions. This is really cool. And thank you so much, Bogdan. We'll switch over now to Ryan's talk. And remember, Bogdan will be in the A area. That's the upper left. Okay. See you later, Bogdan.
Bye.
Hi, I'm Ryan. I'm going to tell you about a new HTTP client library that I built with support for HTTP2. I'll start by explaining why I built it, then I'll give you a little demo of what I built, what kind of state it's in, and then I'll finish up by talking about how I built it using the features that Racket provides. So here's my little motivational caricature of web API programming. Start by copying some previous thin wrapper library and adapt it to the new web service. Right, and there are good reasons to have some sort of wrapper library so that you can enforce invariants like every time you perform a request, add certain header fields, maybe like a client ID or an authorization token or whatever. But at some point, the generalizations and the specializations don't quite fit together perfectly, and you start needing to add flags and dials and callbacks and parameters and all this stuff to keep things sorted out. And just, it becomes kind of a mess, or at least that's my experience approaching it with functions and parameters. So I wanted to try a new approach to building a client library. And in particular, I wanted to build a foundation to support customization. And so I think that accepting a little bit of complexity up front and accepting this idea of some assembly required will make a cleaner foundation and a better experience overall. So that's the primary goal, and I have thoughts about how to do that. Other goals are to build the core implementation using asynchronous operations, and related to that is support for HTTP2. So along with those goals, I have some opinions about Racket library programming. I feel like in general, Racket's class system is underappreciated. So most of the non-trivial Racket projects that I have built use the class system in some way or another. It's just a useful tool for managing complexity through fairly standard object-oriented design. I think that parameters are probably overused in Racket. So parameters are often used for similar sorts of things. The problems come in, especially when you have higher order code. So you have callbacks. One problem is matching the dynamic extent of the parameterized to the identity of the task that you're actually trying to control with the parameters. Another problem is that when you have multiple parameters, you kind of want to collect them together into some sort of coherent abstraction that you apply together, and you want to group that with the operations that it applies to. And when you're grouping multiple bits of state together with behavior, well, that's kind of what the object system was invented for in the first place. So this is kind of my perspective that motivated my my client design. So let's look at the demo. So here I have a module. It requires HTTP 123, which is my library. It also requires Racket's JSON support. I've set up a little server, and I have a helper function for making requests to that. And then here I create the HTTP client object. SSL certificate verification is disabled because this is localhost. I want to consistently add the occasion RacketCon 2021 header field to all of my requests, so I can do that at one point here. And then by default, HTTP clients don't know how to handle anything, really. So this is the some assembly required part. So I have to tell it, I expect these two kinds of content. Text plain, just handle that by reading the entire content as a string. And application JSON will parse that using read.json. So that's the setup of the client. And then I can perform a request by calling the handle method and a request structure. And so if I do that at the hello URL, then I get a string hello from the server. Let's see, here's another URL. I can ask for the date, and I get a string. Both of those are sent as text plain. I can ask for a date JSON, returns application JSON, and that's parsed as a JS expr containing the month, the day, the month, the year. Okay, so that's the basic idea of the client handler interface. Here's one more thing that we can do. We can bypass the handlers entirely by just asking for the response object. And we do that by calling the sync request method instead of the handle method. And if we do that, then we get a response object that contains the status code, the initial request, and here we can see that occasion was added to the request header. We can see the response header fields and so on. We don't see the content, and that's because if we just ask for the response object, then the content is still in a port. So we can get to that by calling send r get content in. Right, that returns a port, and so we can just read the entire port contents and return that as a string by using port to string. And there we see the serialized form of the JSON document that the response included. If we call that again, then we get nothing. We consumed the content in the previous call, and the library doesn't buffer it or save it somehow. Okay, let's try one more thing. Let's ask for a memory. So now I get an error because the server returned a 303 response. That's a redirection response. By default, the client only knows how to handle 200 OK responses. And so in order to handle a 303, we have to add a response handler. And we could add a handler for 303, but let's go ahead and handle the entire class of redirection responses. And we can do that by calling the handle redirection helper method on the client object. And we give it the response that represents the redirection. This isn't done automatically, but we can just add a handler that does this. Although, maybe we don't want to actually use the same client in order to handle the redirection. So I have this non-standard header here. And I know that my server handles it fine, but I don't want to send this to wherever I'm being redirected to. And especially if this were something like an authorization token, I might be hesitant to follow redirections using the same client. So let's do this. Let's define a base client and say we always handle redirections using the base client. And then the client that I'll actually initiate the request with will be defined by making a copy of the base client, preserving all of the existing behavior, all of the handlers, but also adding this header field to all of the requests. And so now I can repeat the request. The initial request will contain this header field, and I will handle the redirection with the base client, which does not include the header field. Okay, so let's try that. Okay, so we still have an error, but it's a new error. So the redirection worked. And now we have an error that says, I got a 200 response with an image ping body, and I don't have a handler, I don't have a content handler set up for that type of content. So let's add Racket draw, and let's pretend for now that read bitmap can handle all kinds of images ever. It certainly handles image ping. And let's retry the response. Let's retry the request. Okay. And so now we have a nice photo from RacketCon 2018. Happy memories. All right. Here's another demo. We have a similar client set up. We're going to look at a post request to this search URL. We don't want to add any additional header fields. And the body of the post will be this JSON object saying to search abstracts for the word syntax. Okay, so we'll see what that does. Right, and then we've added some other stuff up here, and I'll explain that in a second. Okay, so if we run this request, we get the following results, and it's a list of JSON objects describing talks at this RacketCon that mention the word syntax in their abstract. Okay, so that's fine for the result. Web APIs often limit the number of requests that you can make in a particular time span, and they will often tell you about your usage so far by including header fields in the response. Like you've done so many things, or you have so many remaining, and the current window refreshes at such and such a time, for example. And so on the one hand, it's nice that those are in the header because it means that it doesn't interfere with the response content. But on the other hand, you have to go looking through the header for it, right? And that can be kind of inconvenient. So one way of handling that is here. I've defined a global variable, a mutable variable called search is done here. And I have a response listener that looks in the response header and gets the integer value of the search is done header field, if there is one. And if I found one, then I simply update the global variable to have the latest information from the server. Okay? And then I register that listener as a callback with the client. Okay? And since I've just executed a request, I can ask how many searches have I done? And one so far. Okay, so that's another kind of callback that you can build into your client to access this kind of information. Another approach would be to override the default success handler to handle the content and then combine that somehow with the result of getting the header information that you want. That's another possibility that would avoid the mutable variable. Okay, so for the final demo, let's talk about asynchronous requests. So the client is pretty much as before, and now I'm making two requests, one after the other, and the first one takes a while. So I wait and I wait, and then eventually I get two responses almost immediately after one another. And the reason is that I don't even make this request until this one has returned. Right. So instead of making the requests synchronously, let's use async request to make the requests. And now I issue both requests and I get results immediately, but I don't have responses yet. I have events that I can use to wait for the response. And so I can do something like sync. I can sync on the slow or the fast response. The event, the result of synchronization isn't the response itself, it's a procedure that when applied will return the response. So in order to actually get the response, I need to apply it. So I can do it like that. Okay. And of course I can also sync on the result of wrapping them with something that distinguishes them so I know which one I've handled or I take additional action. Basically, once you have events, you have this whole catalog of event combinators that Racket provides for dealing with them and handling them. Okay. So that's what asynchronous requests look like using this library. Okay, so that's the what. Now I'll talk briefly about how I built this library. So let's start by looking at the basic picture of HTTP2. So the thing that HTTP2 adds is stream multiplexing. So instead of in HTTP1 making a connection, making a request, waiting for that request, or possibly pipelining another request after it, and then waiting for them one by one. In HTTP2, once you have a connection established, if you want to make a request, you simply create a new stream that is multiplexed with all the other streams. You send the request for that stream, you receive data on that stream independent of any other existing stream. And so the data can be interleaved. You might get the request made second actually arrives first. No problems here. Okay, so that's the kind of the communication story for HTTP2. Let's look at the implementation. Here are the objects involved in the implementation in this library. So we have the client, excuse me. We have the client object. This is the one that you saw. This is the primary user visible object. Contains all the handlers and callbacks and helper functions for things like redirection. Connection is kind of the heart of the implementation. It's the switchboard. It handles the stream multiplexing. It also handles a few things like header compression, because that you want to use compression information across different requests to compress headers. It has some connection global flow control state, but mainly it's responsible for doing the stream multiplexing and dispatching received frames to the appropriate stream object. Okay, The stream is actually represented by two partner objects. There's one for the low level behavior, like the protocol, the framing, the flow control, stuff like that. And then there's one that operates at a higher level that cares about things like the header that I received. Does it have a field for the status code? Is this the real response, or is this some informational nonsense? So there's the high level that actually cares a bit about the HTTP2 protocol per se. And then finally, so that object forwards data through box events and ports to the response object that is mostly a container, but also does some things like handle content decompression. Okay, so those are the objects, but that's only half of the picture, and the other part is the threads. Okay, so here's what the thread picture looks like, and the overlapping of the object boxes and the thread boxes is very deliberate. So you see the client and response objects are in this sea of user threads, maybe one, maybe many, maybe the objects are accessed by multiple threads simultaneously. The user thread world is scary, and the goal of this library is to protect the connection implementation from the user threads as much as possible. So it creates two threads of its own that handle almost all of the work that the connection does, the manager thread and the reader thread. And the reason for that is connections contain mutable state, and the easiest way to manage mutable state in the presence of multiple threads is to only let one thread have access to the mutable state. Okay, so all of the mutable state in connections and also the stream objects is only ever accessed by the manager thread. And the reader and user threads communicate with the manager thread through special thread communication primitives. Okay, this design is kind of, it's the heart of concurrent ML, which is where Racket gets its synchronizable event system from. I learned about it, I think, mostly through this paper about kill-safe synchronization abstractions by Matthew and Robbie. Although I'll point out, this design that I'm showing right now is not kill-safe. But the core idea of having one thread communicating with others and managing local state exclusively is the same there. Okay, so what are these primitives? Well, we have a thread mailbox, and the reader and user threads simply communicate with the connection. They communicate with the manager thread through its thread mailbox. Okay, so when the reader receives a frame, it just sends the frame to the mailbox. Streams, if they need to do work, create events that represent their ability to do work and the work that they need to do. I'll give you an example in a second. And then the manager thread simply loops on syncing these different event sources, right? Did I get something in the mail? Is a stream ready to do work? No, okay. And so what does a work event look like? So here are two examples. If the stream is in the mode where it is sending request data, that means that there's a user thread that is writing to the request data pipe, and it wants to send that to the server. Then it's only able to do work if the flow control system says it's allowed to send data at that point. If it's not, then it can't do any work at that state, and it should check later. Otherwise, if there is request data in the pipe to send, then go ahead and send it. That's the work event in that state. In the state where the stream is receiving response data from the server, well, the response data itself is being received by the reader, it's going into the connection mailbox, and then the connection object is directly invoking the stream and app methods that send data through the pipe to the response. So that's not what this event, that's not what this work event is covering here. It's covering the tiny back arrow where if the user reads from that pipe, then we should update our flow control information, tell the server that we're ready for more data. Or if the user closes that pipe, we should tell the server to stop sending. And so we handle that by waiting on the pipe progress event that simply reflects, it becomes available when either of those situations happens, and then we update the server with new information. And then finally, these pipes, they're actually custom ports that allow us to send exceptions over to the user thread. So when they attempt to read, if there was a protocol error or server disconnect, then they get an exception from the read attempt. The box events don't support that features, which is why they contain procedures rather than the values directly. And this is simply a pattern that we program to when using box events. Right. And that is the map of the implementation. And the library is available on the package server. It is tested but not used in anger. So I invite you to help me track down the remaining issues. That's it. Thanks.
Thank you, Ryan. Let's go through some questions. Okay, so the first question is, can you tell us a little bit about HTTP 2 and what is special about it, as opposed to just HTTP 1?
So the main special thing is the stream multiplexing. Mm-hmm. And that creates opportunities and challenges. Let's see. There are also some things that I didn't talk about too much. I mentioned flow control. Flow control gives you more opportunities to say things like, I want you to stop sending me data about this thing, but keep sending me data about this. And there is also a priority system that currently I don't implement at all. So it lets you say more things about the communication to the server, some of which are taken advantage of and some of which aren't. It does header compression, that's new. So in terms of implementing HTTP2, it's much harder and it's a much steeper slope. You have to write a lot more code before you get anything working at all. For example, a server can do header compression and it can use a Huffman code to compress certain strings and not others. And that's not under your control, it's under the server's control. So you don't get to just opt out of that. Oh. And so that's another thing that went into the implementation. I had to do Huffman, basically a prefix code codec, and that's in the binary IO library now, which was fun, but was another step before anything works at all. So that's what I meant by a steeper curve.
Oh, interesting.
But if it's one thing, it's stream multiplexing.
Yeah. Now, one person asked the question whether or not the Racket web server implements HTTP2, and I mean, I know the answer to this. The answer is no, it doesn't. And is there, obviously a client is very different than a server, but like sometimes client code is very similar to server code and the algorithms that they use. Do you think that what your library is gets us anywhere closer to having a Racket HTTP2 server?
Yes, I haven't finished it, but I have. So the communication part is pretty easy to build out of the pieces that are already there. The main thing is the stream layer, and I recently refactored that so that you really could just reuse a lot of the same stream building blocks and just run it in server mode. So the communication part is, I think, already there, although without testing, I could be wrong about that. And then the only work that is left to do in order to have something that you could call an HTTP2 server is just the adapter level. Like we receive headers, and I have my representation of a header, which is not the same as the web server's representation of a header, right? And a request object or a structure in the web server has already parsed things. Like I think it has already parsed like multi-part message bodies into bindings and files and stuff like that. And so you would have to do that kind of parsing also. Which means that the server actually needs to read message bodies eagerly rather than on demand.
Yeah.
So yeah, it's hooking up those wires. Oh, the other major thing that is in a pull request that I haven't finished up. I've gotten preliminary feedback. We need the SSL library to support ALPN on the server side. So when I did the original version of this library, I added ALPN support for clients, but not servers. And now I have a pull request to do ALPN for the server side.
Now, in your journey becoming an HTTP2 expert, which you now are, know if like proxy servers like Nginx will just give you multiplexing for free when they're proxying a backend that doesn't support it? Like, should we even bother making Racket web server?
I mean, in fact, that is how I test it. In Nginx, we'll do multiplexing by making multiple connections to the backend server, and that speaks HTTP1. So if you look in the test directory, there is a little thing for setting up. I think it's ng HTTP TTPX, which I realize now I don't know if that's actually from Nginx or if that's another little lightweight thing. But yeah, it's done by reverse proxying using the Racket web server. And by the way, dispatch rules is the coolest thing ever for writing little testing apps. Yeah, it's beautiful.
Cool. Okay, so here's another question. And basically, I feel like you've there's a hidden flame war behind the scenes of this question, which is that you, and I know this about you, Ryan, you have been a class advocate your whole life. You have been really into classes for a long time, and I feel like there are lots of people like you and Robbie formed the class cartel among racketeers, where so many people they're opposed to these things, and so someone wants to get involved in this fight. So I'm going to read you their question.
Okay.
They say, compared to parameters, it's more difficult for me to explore classes using binding information, and there's no support for navigating methods because classes are first class. How do you deal with this? Do you understand this question? I feel like I understand this question.
Yes. So I agree, by the way. Like classes expose, Racket's IDEs have less support for understanding and helping you with classes. And that's true. And the answer is I deal with it by keeping stuff in my head or by switching tabs and looking at stuff. But I agree.
Get good.
I don't know that that's a similar, so the issues with parameters are just of a different kind. So I'm not sure that they're really related.
When he says parameters, I believe that he means like argument names, like using parameter in the sense of like binding names. So
yeah, so I think that parameters, as in parameter values, parameter objects, are overused.
Yeah.
And so that's kind of my fight.
Yeah. Perimeter values, you can convince yourself that they're not state, and then, oh well, they're like safe, but they really aren't state, and you'd use them in lots of statey ways, and that can be painful. Now,
Yeah.
here's kind of another question that's in the same vein of the class flame war in your examples. I feel like your HTTP clients, because you're creating an object and you're saying, if you get this kind of thing, handle it in this way. This is basically like, rather than the client providing me data, I provide the client a code, and that code is going to obey a particular interface about how it interacts with whatever ends up happening. And this is like very much like an object-oriented idea, where rather than producing data objects, I instead am passing around behavior. And that is really ingrained in your HTTP client because you're doing it right there in those response handlers. And you didn't just have like, when you first showed it to us, it's like, okay, well, read JSON or turn it into a string. Those are like boring handlers. But then in your examples, you get these ones that are like, well, I'm actually going to like do the query right here on the data. So can you talk about like, can you pitch that way of thinking more for someone who is, a heretic who thinks that, we should turn everything into, const char arrays before thinking about them?
I don't understand the contrast. I mean, I think that the way that I prefer to work with web APIs or web resources or whatever is certainly I have an expectation about what I'm going to get back. And I want to build a client that gets that resource and in the common path gives me the data in the form that I want to work with it. So if I'm making a request to an API that returns JSON objects, I want to receive the data as a JS expert, right? And then, yeah, to handle uncommon cases like redirections or client error or server error, whatever, then I want something to handle that behavior. And I think that doing that kind of out of line, not in the return path, but as yet another handler that you install on the client is probably a nice way of doing that. I didn't really understand the bit about const char array, but
what I mean is just that if the only job of the HTTP client is to hand me a bucket of bytes, and then I'm going to go process those bucket of bytes later, I think that there's what I'll call a naive functional programmer argument that like, well, a bucket of bytes is way better than passing around, like behavior, because you want to have 100 functions on one data type rather than, 10 functions on 10 data types. And so by baking in what I'm going to do with the data into the HTTP request itself, it's sort of like removing this like flow orientation that we've seen earlier in the day, where you produce something and you process it and you process it. And my guess is that your take is that HTTP2 in particular allows back and forth communication between the server and the client. And so there's just a much richer perspective about what you're going to do with the data once you get it. Although you shook your hand, so you're saying
it's not about HTTP2 at all. It's if you're making requests from different points in the code, I think that you are going to want to process the results in similar ways. And so if you just return an array of bytes, then you're going to have to call similar functions to process those arrays of bytes in multiple places scattered around your code. And that's bad, right? That's the kind of thing that you want to eliminate and bring under a single point of control, right? And so that is the assumption behind the design of this style of client. If you really don't believe that, like if you think that every different part of the code is going to process things in a fundamentally different way, then yeah, you will not care about this style of HTTP client. But on the other hand, you don't have to install any handlers. You can just use sync requests to get a response. and then do the case analysis and, oh, what is the status code? Is it 200? Is it 303? Is it 307? Is it, okay, if you want to write that in all of the call sites, then you can. But I don't want to.
Yeah. I mean,
and so the other thing, the similarities also across different. So you can imagine having adapters like this get is specialized to JSON. And my point earlier was it's not just get. There's also post. There's also put. There's also occasionally other things, and making the same kind of abstraction over multiple underlying functions is just a pain. And that's part of why I think parameters are not a good solution here either.
I see. Now, let me ask you one final question, which is like, why did you put yourself through this? I mean, like, are you just need to have HTTP2 support in the Racket world? I mean, there's no service there that you can't get if you just use HTTP1. Do you just what's wrong with you? Why did you write this?
Who wrote that question?
I mean, I'm grateful and it's beautiful, but I want to know why?
Yes. I mean, I feel like we should all be on a quest to figure out how to solve problems in a way that makes us happy. So that's part of it. I was thinking about writing something involving the web, and I just looked at the tools that I had, and I looked at the tools that were currently available. This is before some of the most recent libraries. Not trying to criticize my competitors, but and I'm not happy. I'm not happy dealing with this using these tools. I think the taking pleasure in creating and using good tools is, I think, part of what defines us. And HTTP2, I thought that Racket really ought to have that, and it's kind of like a mountain because it's there.
Yeah. Well, cool. Well, we're all benefiting from your work. Well, cool. Well, thank you so much, Ryan. We're gonna go now to the hallway side of things, and Bogdan will be in area A, which is in the upper left, and Ryan will be in area B, which is in the upper right. And we will reconvene in 45 minutes for the final session of the day. Thank you so much, everybody. The live stream will go off and we'll turn it on again in about 45 minutes. See y'all later.